Hello friends, this video Binomial Theorem part 14 is brought to you by examfear.com. No more fear from exam. Before watching this video, you should have watched Binomial Theorem part 1 to part 13. In this example, we have to show that coefficient of the middle term of expansion that is 1 plus x to the power 2n is equal to sum of two coefficients. This coefficients of two middle term of expansion 1 plus x to the power 2n minus 1. We observe that in the first expansion 2n is even. So the total number of terms in the expansion will be 2n plus 1 and that will become odd. So in case of odd number of expansion, for example say 1, 2, 3, there is only one middle term. So we'll have one middle term. In second case 2n minus 1 is always odd because this odd minus 1 is odd. Even 2n is even, minus 1 is odd, and the total number of terms will be 2n minus 1 plus 1. So this will become even. So in case of even, you see there will be two middle terms. There will be two middle terms. Now we are told that the middle term in the first expansion should be equal to sum of two middle term in the second expansion. So let's try to first find tr plus 1 for the first equation. It will be of form 2ncr x to the power r 1 to the power 2n minus r. 2n minus r 1 to the power will be equal to 1. So this will become 2ncr x to the power r. This is for 1 plus x to the power 2n. For 1 plus x to the power 2n minus 1, tr plus 1 is equal to 2n minus 1 cr x to the power r, and here also 1 to the power 2n minus 1 minus r. This will become 1 to the power anything become 1. So this is equal to 2n minus 1 cr x to the power r. So if you see, the coefficient is 2n cr for tr plus 1, and in this case the coefficient is 2n minus 1 cr for tr plus 1. So now what we have to prove that? We have to prove that coefficient of the middle term. First let's try and find the middle term of the first equation. Since the total number of term is odd and the power is even, that is 2n, so let's write for the first equation 1 plus x to the power 2n, the middle term. For this, the middle term will be this 2n divided by 2 plus 1. So that becomes n plus 1. So you see here also, if you see, the middle term is total number, that is here in this case 3 divided by 2 plus 1. No, sorry, 2 by 2 plus 1. So here also, that we have also learned in the past slides that in case of 1 plus x to the power even number, the middle number is even number by 2 plus 1. So here the middle number is n plus 1th term is the middle term. In case of 1 plus x to the power 2n minus 1, we have to find two middle terms because this guy is odd. So there will be even number of terms. For even number of terms in the series, there are two middle terms. So middle term in this case is, we have already learned in the past slide that this is 2n minus 1, this is 2n minus 1. So this will become 2n minus 1 plus 1 by 2, and whatever you get here 2n minus 1 plus 1 by 2 plus 1. So this becomes, this is cancelled, this becomes n plus 1. So n and n plus 1th term are the two middle term for 1 plus x to the power 2n minus 1. So we have got middle term of 1 plus x to the power n, that is n plus 1, and we have got the two middle terms of 1 plus x to the power 2n minus 1, that is nth and n plus 1 term. Now we are told that we have to prove that coefficient of the middle term expansion this is equal to sum of the coefficient of this, that is coef of n plus 1th of 1 plus x to the power 2n. This guy is equal to coef of n plus 1th, you add this, of 1 plus x to the power 2n minus 1. This is what we have to prove. Coefficient of nth term, n plus 1th term of 1 plus x to the power 2n is equal to coefficient of n plus 1th term, both you add, of 1 plus x to the power 2n minus 1. That is what we have to prove. So we'll do that. T of n plus 1 term is equal to 2n cr. So here we replace r by n, so we'll get 2n cn, that is 2n cn. We have to prove that 2n cn is equal to, here in this, for 1 plus x to the power 2n minus 1, tr plus 1 is equal to this. So here if we put r is equal to n minus 1, so we get t of n minus 1 plus 1 to get t nth term. So what we get here is 2n minus 1 c of n minus 1. This is t nth term. So we'll write 2 of n minus 1 c of n minus 1 plus, for n plus 1 term we'll put r is equal to n. So t of n plus 1 is equal to 2n minus 1 c of n. So this will become 2n minus 1 c of n. What we have done here, so we have been told coefficient of n plus 1 term of 1 plus xn, x to the power 2n, so that is nothing but 2n cn, and coefficient of nth and n plus 1 term of 1 plus x to the power 2n minus 1, that is nothing but 2n minus 1 cn minus 1 plus 2n minus 1 cn. So we have to prove that. So now we can apply this formula where ncr minus 1 plus ncr is equal to n plus 1 cr. So this one here we'll say 2n minus 1, or we will say k, just to make things better. We already used n here, so we'll say 2n minus 1 is equal to k in this formula. So n minus 1 is equal to r. So this thing will become, if you see, right, if we say 2n minus 1 is equal to k and n minus n is equal to r in this formula, if you put here, so this becomes k, this becomes c r minus 1, this becomes kcr, and this should be equal to k plus 1 cr. So if you see, k plus 1 is nothing but 2n and n is r. So this formula is proved. This is correct, and that's the answer. So what we have done, we have found the tr plus 1 term of 1 plus x to the power 2n and 1 plus x to the power 2n minus 1. So we have written that. Once we have written the 1 plus trth term of these two expansion, we found the middle term. For middle term of 1 plus x to the power 2n was n plus 1th term, and middle terms for 1 plus x to the power 2n minus 1 was n plus 1th term. So we were told that coefficient of n plus 1th term of 1 plus x to the power 2n was equal to coefficient of n and n plus 1th term of 1 plus x to the power 2n minus 1. We have to prove that. So we have found the coefficient here from these equations which we have created, and we have placed it, and we found that if we use this formula kcr minus 1 plus kcr is equal to k plus 1 cr, with this formula we are able to prove that. Thank you. Visit examfear.com to watch free educational videos, try free online test, get the best quality study material, study from the best tutor and mentors, and much more. Thanks once again.